Good day, class. Our topic for today has something to do still with the concept electronic structure of matter, but to be more specific for this particular video recorded discussion, our focus is on electronic configuration, valence electron, and Lewis electron dot structure. Here are the learning objectives. First, describe electron configuration and write the correct electron configuration of given elements. Second, draw the orbital diagram of the given element. And third, draw the Lewis electron dot structure of a given element. From our previous discussion, you've learned about the concept quantum mechanical model. In this topic, you've realized that this model will allow us to identify or determine the probable location of electrons, as well as it gives us an information on the proper way to describe its energy through quantum numbers. Now, electron configuration will help us to describe how electrons are distributed among the energy levels, sublevels, and orbitals based on the given or based on the governing set of rules. Just a recall, remember that the main energy is equal to the number of sublevels. And there are different kinds of sublevels denoted by S, P, D, F. And each sublevel corresponds a certain number of orbitals. Now for S, there is only one orbital. For P, there are 3. For D, there are 5. And for F, there are 7. Take note of these numbers because this will be used later on the given or as we try to understand some of the rules for electron configuration. Okay, just to add, remember also that for S, it can hold less than or equal to 2 electrons. For P, it can hold less than or equal to 6. For D, it can hold less than or equal to 10. And for F, it can hold less than or equal to 14. Okay? And later you will realize why these numbers are for this particular sublevel. Okay? Or orbital. Now let's talk about the different governing rules for electron configuration. First is the up-bow principle. The up-bow principle states that in order to fill the orbitals with electrons, start from the orbitals with the lowest energy levels before occupying orbitals with the higher energy levels. So, this is the mnemonics used to identify the correct order of energy levels in an atom from the lowest energy level to the highest energy level. Okay, so also you see here orbitals like 1s. The orbital comprises of the main energy, as what you've learned from our previous discussion, and sublevel. So the main energy level here is for 1s, 1, and the sublevel here is the s. So the other sublevels include P, D, and F orbitals. So as what I mentioned earlier, it can occupy a maximum of 2 for S, P for P6, D10, and F14 electrons. Again, the up-bow principle requires us to start when writing the electron configuration of an element to start with lowest energy level, moving to a higher energy levels. Now, next rule to follow for electron configuration is the Pauli exclusion principle, which states that only two electrons may inhabit an orbital and they must have different spins. Now, as you've noticed on the given illustration, the different spin directions of these electrons are by convention designated as arrows, like you've noticed here. The first electron is denoted by an arrow pointing upward, this one, and the second one is pointing downward. Okay, so electrons are said to be paired if they are found in orbital with opposite spins, and unpaired if only a single electron occupies an orbital. So that will be further intensified later on as I give you examples. But what I wanted you to remember here in Pauli exclusion principle is that an orbital can only inhabit two electrons with different spins. One is upward and the other one is downward, as represented by an arrow. Now let's talk about the last rule for electron configuration, that is the Hans rule. Hans rule states that when electrons are to occupy orbitals, electrons having the same spin, which is parallel, fill up the same energy level orbitals before pairing up with electrons of the opposite spin. So we know it already that the arrows are the one that represent the electrons, and an orbital can only inhabit two electrons. Now, to understand this, let us focus on how we draw an orbital diagram. Note that an individual orbital or orbitals within the same sublevel are represented by squares. Each square is labeled with its principal energy level and sublevel. That could be 1s, 2s, or 3p, or so on and so forth. The arrows are for electrons. You know it already. Upward arrows are first drawn here and distributed in each box representing the same principal energy level and sublevel, followed by a downward arrow. So you have to begin with filling each box with upward arrow before proceeding to the downward arrow. Now, to practice that one, let's take a look at the correct way of drawing the orbital diagram of an example element, which is element phosphorus with atomic number of 15. You've learned during your grade 8 chemistry that atomic number is equal to the number of electrons and protons. So whatever the atomic number of an element, that is the number of electrons, and that is the one we try to distribute in main energy level, sublevel, subshell, so on and so forth. Now, this is wrong because if we follow the Hans rule, we have to first draw the upward arrow and we have to distribute that in each box. So again, this one box is for a certain orbital, and that is for s orbital. Okay, the number here is the main energy and the s is the subshell that correspond to the orbital. Okay, hope you follow that one. Now, this is another one box for 2s because again, the orbital that can only for s orbital, there is only one orbital. Okay, for p, there are 3. That is why there are 3 boxes here. Okay, and for d, there are 5. So if you will draw the orbital for d, so there should be 5 boxes. and for F there should be 7 boxes. Okay, so that's the importance of remembering the number of orbitals, so that once you draw the orbital diagram of an element, you know the number of boxes for each orbital. Okay, again, this is wrong because you've noticed that in each box you draw the upward and downward arrows. Again, before you draw the downward arrow, you have to start with upward arrow, finishing that in all of the boxes presented in each orbital before proceeding to the downward one. Now, this is the correct version because you've noticed, comparing it to the last orbital, which is the 3p, arrows are distributed first before downward. There's no downward arrow here because, again, if we're going to count it, we should only distribute 15 electrons. Okay, 15 electrons only. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So again, for this s orbital, we draw the upward and downward because there are only 2 electrons pa lang for the 15 electrons that we have to distribute. Okay, for 2s, we can actually start drawing the upward and downward because if you're going to add them, 4. So, hindi pa rin yung 15. So, for 2p, upward first before the downward. So, all orbitals contain 2 electrons because once we add it, 6 plus 4 is just 10. So, the remaining electrons that we have to distribute in each orbital is 5. So, for 3s, s contains 2 electrons because this is only 1 box. Okay, for the orbital. So, you can complete it na, upward and downward. But again, you should start with upward before downward. So, here, upward lang kasi there are 3 boxes that we have to fill in. We have to start with the upward first before filling in the downward. We cannot put here downward arrow again because the only electrons that we have to distribute is just E. Okay, so that is Hand's rule. But nothing to worry, this will be further intensified as I give you examples later on. Another concept that you have to remember also for electron configuration is the valence electron. So I know it already that you have an idea. You've learned it when you are in grade 8 that valence electron or electrons are the electrons in the outermost energy level. So later I will teach you how to identify which one among your electron configuration from the orbitals that you wrote or write there, the outermost energy level. Okay, but again, the electrons found in the outermost energy level, that is the valence electron. Also, the valence electron is related to the group number of an atom in the periodic table of elements only for represented elements or your main elements in the periodic table. That is found here, group 1, 2, so on and so forth. The one with colors here in the given picture. Now, the portions in your periodic table here, as you've noticed, with no color, is known to be the transition elements. So you can't use the valence electron of those transition elements to identify their group number. Okay? So please note for that because I know you learned the reason why when you are having the discussion during your grade 8 chemistry. Now let's apply the different rules which I discussed earlier, as well as the concept of valence electron by answering these examples. Let's have the first example. Write the ground state electron configuration and orbital diagram of sodium with atomic number of 11. Again, ground state, that is the only way of writing the electron configuration of an element. Again, there's an excited state electron configuration version, but for this discussion, we are focusing only for ground state electron configuration because the atom is at neutral state. Okay, so hopefully you can recall the difference between ground state, excited state when you have the discussion during your grade 8 chemistry, as well as neutral state of the atom. Okay, so again, we are writing the ground state electron configuration of a given element, as well as we are having example elements that are known to be neutral. Okay, neutral because they have same number of electron and proton. Okay, so the element is sodium and the atomic number is 11. I already mentioned it already that the atomic number for neutral atom that is just the number of electrons. Okay, so following the rules, the opt-out, the poly exclusion, and the hands rule, okay, we can definitely go ahead and write the electron configuration for the sodium. And we're going to distribute how many electrons? 11. Okay, 11, that is based on the atomic number of your sodium. So, we have to use the mnemonic device, which is this. In order for us, according to opt-out principle, in order for us to write the first energy level with the lowest energy, moving to the orbital with highest energy. Okay, so by following this, we have to start with 1s. Okay, and we have to write the electrons in each sub-level, which is the s, p, d, f. Okay, in each sub-level of orbital as an exponent. So remember, I gave you this values. For s, it can carry or occupy a maximum electrons of 2. It could be less than or equal to 2. For p, less than or equal to 6. For d, less than or equal to 10. And for f, less than or equal to 14. Again, 2 because for s orbital, there are only 2 electrons. For p, because there are 3 orbitals, each orbital can have 2 electrons. 3 times 2, 6. So that's the reason why the value is 6 here. For d, there are 5 orbitals and each orbital can have 2 electrons. 5 times 2, that makes 10. And for f, there are 7 orbitals and each orbital can have 2 electrons. Multiply it to 7. Those electrons, you can have 14. Okay, hopefully you follow that. Now 1s, so 11, we have to distribute that. We can have exponent here, which is 2. So the electrons that we already distributed is 2. So ilan na lang ang kulang natin? Okay, 9, right? So move to 2s according to this mnemonic. So 2s. So how many electrons can only be seen on this orbital? For s, 2 or lesser than 2, but here 11 dahil 9 pa naman, we can write 2. We have to add this, the exponents, just to make sure that we reach the number of electrons that we have to distribute. So for sodium, 11. So 2 plus 2, 4 pa lang. Moving to the next energy level, which is 2p, the next orbital, 2p. And p can have 6 and also lesser than 6. Meron na tayong 4. Ilan na lang ang kulang to make it 11. Okay, so we can write here 6. So 2 plus 2, 4 plus 6, 10. Okay, we can complete that. We have to complete the electrons for this orbital before proceeding to the next energy level. Okay, so hopefully you follow that. So after 2p, move to 3s, right? If you follow this one. So 3s. So we can write here up to 2. But again, when we add this, 10. So, isa na lang ang kulang natin. Since this is less than or equal to 2, we can have here 1. Okay? Hope you follow that one. So, 2 plus 2, 4 plus 6, 10 plus 1, 11. So, we already distributed 11 electrons for this electron configuration of your sodium. So, this is the electron configuration of your sodium. Now, if we're going to identify the valence electron of it, okay, that's the symbol on how you write valence electron. So, sabi, if you're going to recall, the valence electron is found at the outermost energy level. So, the outermost energy level here is the 3s. That is the one with the highest energy level. So, paano po malaman yun? With number that is highest or based on the mnemonic. So 3 is higher than 2. Okay. So 3s, how many electrons can be found in 3s? Only 1. So the valence electron for sodium is 1. Okay, hope you follow that one. Now for the orbital diagram, so remember that S can only have one orbital, so one box. For S, for P, 3 boxes. For D, so I will write here 1, 3, 5, and 7. So these are the number of orbitals. And orbitals are represented by boxes. So this is how we draw the orbital diagram. But following the Pauli exclusion and Hans rule, we have to start writing the upward arrow first. Okay, since this is 1s, there are 2 electrons. Refer to this electron configuration for your orbital diagram. So there are 2 electrons. So up first, then down. Okay, so hope you follow that. So moving to 2s. So up first, then down. For 2p, there are 6. Start with upward first in each box before writing the downward arrows. So that is for Hans rule. Okay? And Pauli exclusion says that there are 2 electrons that may inhabit the orbital. The orbital is represented by square or boxes. Okay? So 3s, how many electrons? Only 1. So that is only upward arrow. So that is the orbital diagram of your sodium, and this is the electron configuration, and the valence electron is 1. So hope you follow that. And again, we follow as well the governing rules for electron configuration and orbital diagram. Let's have the second example, which is write the ground state electron configuration and orbital diagram of bromine with atomic number 35. Again, the atomic number 35 here is also the number of electrons. That is the one that we have to distribute in each orbital. Okay, so as a recall, S can have less or equal to 2, P less than or equal to 6, D less than or equal to 10, and F less than or equal to 14. Okay, so you know it already, the reason why with this particular numbers. And also, S can have 1 orbital, P can have 3, D can have 5, F can have 7. So, bromine, that is the symbol of the element, and the atomic number is 35. That is the one that we have to distribute. So following the mnemonics and the different rules or governing rules for writing the electron configuration, we have to start with the lowest energy level, moving to the highest energy level. Each box can have or can only have 2 electrons as per Pauli exclusion, and Hans rule, we have to start with filling each box with upward arrow before the downward arrow. Okay, so start with 1s. So S can have maximum 2 or lesser than 2, but since 35 naman ang ating distribute, we can write it in. Okay, So, moving to 1s is 2s. Since s can only have maximum 2, write na din natin yan kasi malarami naman tayong i-distribute. Moving to 2p. So, we can write the maximum number of electrons, 6. 2 plus 2, 4 plus 6, 10. So, may 25 pa tayong i-distribute. So, move to 3s. After 2p, 3s. So, 2 as well. Move to 3p. 6. And 4s, 2. Pause for a while. Let's add the exponents. 2 plus 2 plus 6, 10 plus 2 plus 6 plus 2, 20. So, we still have 15 electrons to distribute. Again, exponents are for the electrons. Okay? So, after 4s, next na tayo, pababa to 3d. D can have maximum of 10. Since 20 tayo, can we write the maximum number 10? Yes. Okay? Kasi 20 plus 10 is 35. Okay, wag natin tipirin, okay? We can write lesser value at the end or if that is the last energy level. Okay, pwede yun, pwedeng bumaba. But just to make sure lang na ma-reach natin yung number of electrons that we have to distribute. But for this particular orbital, we have to write 10 kasi nga 35 naman yung ating pinupuno. So after 3D, since ilan lang ang kulang, 30 na to, 5 na lang, 3D, 4P. That is the next. 4P. So, 4P can have a maximum of, or P subshell can have a maximum of 6 electrons. So, isulat ba natin 6? Hindi, kasi 36 na yon once we add the exponent. So, we have to write 5. Bakit 5? P can have less than or equal to 6 value. So, 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 5 is 35. So, that is the correct electron configuration for ground state or ground state or neutral state of your bromine element. Now, for its valence electron, same procedure, we have to look on the highest mean energy level and check its electron, that is the valence electron. Since ang technique na tinuro ni Sir kanina, look on the number which is the highest. So may 1, may 2, may 3, may 4. So 4 is the highest here. Pero may dalawa, so you have to add their exponents. So 2 plus 5 is 7. 7 is the valence electron of your bromine. Now, remember class that valence electron can only have up to maximum number of 8. Yun lang po ang pwede for the valence electron. Exceeding to that number, meaning to say you're wrong. Okay? So, if an electron or if, if an element reach 8 valence electron, that simply means that the element is stable. Usually, in periodic table of elements, stable elements are known to be noble gases. Okay, hopefully you recall that. That was discussed to you when you are in grade 8 chemistry. Moving to its orbital diagram, we refer to the electron configuration. These are the boxes that we have to fill in with the arrows. So, kaya kung titingnan natin, P orbitals have 3 boxes kasi yun yung sabi ng rule. Okay, and D 5. Okay, so kung may F man tayo ng subshell here, you have to draw 7 boxes. Okay, so hopefully you follow that one. Now, Pauli exclusion Hans rule, apply natin dito. So, 2 electrons lang can occupy each box. Upward and downward arrows. That's how we represent the electrons. Pero we have to start filling in upward, okay, for each orbital. Now, since ito ang reference natin, so 1s, may dalawa, so up, down. Likewise with 2s, start muna class sa up, then down. So 2p may 6. So lahat ng malalagyan ng up down, but we have to start filling in with upward arrows before downward. That is based on the given rule. Now for 3s may dalawa, so up first and down. Now 3p may 6, up first, then down. And for 4s may dalawa, up and down. For 3d may 10, so up muna. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now for 4p may 5, so upward muna. 1, 2, 3, then downward 4 and 5. So sir, kulang po ba ito? No. Tama pa rin yan. There's no downward here because as per the ground state electron configuration of your bromine, there are 35 electrons that you have to distribute. Okay? So hope you follow that one. Now let's take a look on the third example. So we have here copper with atomic number of 29. Okay? And I know when you try to write its ground state electron configuration, this will give you this arrangement. Okay? So you've noticed that this is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3p9. So if you're going to add all the exponents, that gives you 29. But again, just to give you an heads up, some elements are exempted from the given rules. The opt-out, the poly-exclusion, and the Hans rule. The observed ground state, or the predictive, the observed ground state electron configuration may deviate from the standards due to the intricate electron interactions in orbitals with similar energies. So class, these are common among the transition and inner transition elements like your copper. So the correct electron configuration must be this. You have to complete first the value of the 3D because that is, if you're going to look on the mnemonic, okay, you have to complete the energy of that, the electrons of that before completing the 4s1 or the 4s rather. Okay, so that makes it 4s1. So also for silver, this is also part of the transition elements rather. So with atomic number 47, this is your predicted ground state electron configuration, but this is not the correct version. It should be this one. Again, so this is due to intricate interaction in orbitals with similar energies of your electron. Okay, so this is common to your transition and inner transition elements. In most cases naman, the given examples or the given items are for represented elements. Okay? So, huwag kayong malilito doon. Again, if the given examples or the given items is an element found in inner or transition elements, you have to be mindful of the proper way of writing their ground state electron configuration. Punuin muna yung lower energy level with your highest energy level, like with 3D and 4s. Okay, 4 is higher, the main energy of it than 3. So, kompletuhin muna natin yung sa 3 before proceeding to 4. Okay, like with 5, punuin muna natin si 4 before filling in the electron for 5s. Okay, so hopefully you follow that one. Now, another concept that I want you to focus on is about Lewis electron dot structure. Now, in this case, it was proposed by Gilbert Willis, and this will allow you to illustrate the electrons in the outermost energy level of an atom. So that is the valence electron. Okay, the outermost electrons the electrons found in the outermost energy level. So follows octet rule. So pag sinabi nating octet rule, valence electron should only have up to 8 maximum. Okay, and can help picture out how chemical bonding takes place between elements. So this is important concept because this will be used once we discuss chemical bonding. So this is how you illustrate the LEDS or the Lewis electron dot structure. So bakit po 4 ang dots? For carbon, so you have to remember the element symbol. So around the element symbol, you have to put dots, and the dots represent the electrons. Okay? Bakit 4? Dahil 4 po ang valence electron ng carbon. Okay? When you check the electron configuration, valence electron of carbon is 4. So the manner of writing the dots should be clockwise. Okay? Dapat all of the sides, 4 sides of the element symbol. Okay? So also for Lewis electron dot structure, remember that elements with fewer valence electron are mostly metals, and they tend to lose electrons just to achieve stability. Yun yung sinasabi ni Sir kanina. So, maximum electrons per valence electron is 8. Tapos pag 8 ka, stable na yung element. But again, this will be further discussed once we reach chemical bonding, the topic chemical bonding. Pero what I want you to remember muna, yung konsepto kapag metal ka, you have fewer valence electron and you tend to donate your electrons to the other elements just to reach stability. Okay, yun yung tatandaan nyo muna. And elements with more valence electron, syempre, di na sila magdodonate. They tend to accept electrons just to reach stability. But exemption to the rule is the carbon element. They tend to share electrons to become stable. They doesn't donate or even accept, but they share. So this will be further intensified soon. Yan yung tatandaan. So this is important for you to identify whether an element is they tend to lose, accept, or share. Yun yung tatandaan. Okay? So I will mention some of the elements that are exempted to this once we have the concept chemical bonding. Okay? For the meantime, ito lang muna tayo, class. Now, let's have an examples for us to properly illustrate the LEDS of the following elements or the Lewis electron dot structure. So let's have number 1, lithium with atomic number 3. So the atomic number again is the number of electrons that we have to distribute. So we have to write first the electron configuration, identify the valence electron kasi nga the valence electron will be the one to allow us to identify the number of dots that we have to indicate in the element symbol. Okay? So, following the mnemonics. So, 1s2. So, tatlo lang to. So, moving to 2s. So, we have to put 1 here as an exponent. So, the valence electron here, how many? Look on the highest main energy level, which is 2. So, the exponent is 1. Now, for the LEDS class, write the element symbol. And since the valence electron is 1, so we have to place here 1 dot. So the placement of dots should be clockwise, okay, around the 4 sides of this element symbol. If you follow that. So second example, we have magnesium with atomic number 12. So that is also the electrons, number of electrons. Following this mnemonics, 1s2, 12 electrons, yun yung dapat natin distribute. 2s2, moving to 2p, 6, may 10 na tayo, and 3s2. So since 2 na lang ang kulang, so we have to put that here kasi maximum naman ng s is 2. So adding all the exponents just to check, we have 12, right? So Valence electron, look on the highest main energy level, which is 3. So look on its exponent, we have 2. So the LEDS of this one is, copy the element symbol, Mg. So we have to put here 2 dots clockwise around the element symbol, side by side, ha? 1, 2. Okay? So, third one, we have fluorine with element atomic number 9. Element symbol is F. So, electron configuration 1s2, 2s2, 4 na to, 5 na lang, 2p5. Okay? 2 plus 2, 4 plus 5, 9. Okay? So, ulitin natin, pwedeng mas lesser than 6, but you should not exceed beyond this maximum number for orbital. Okay? So, valence electron, look on the highest main energy level dahil may dalawang 2 other exponents. 2 plus 5 is 7. Now, the LEDS of this one is, copy the element symbol F. There are 7 dots that we have to place around the sides of this element symbol clockwise. 1, 2, 3, 4, 5, 6, 7. Okay? So that's how we illustrate the LEDS of fluorine. Now class, as mentioned earlier, the valence electron could also inform you if the elements tend to lose, accept, or share electrons. Now for this case, lithium, we can say that this, because konti lang naman at isa lang ang valence electron niya, at knowing that this is a metal element, okay, so therefore this is, it loses its electron, okay, just to reach stability, yun, okay. So if you're going to look on naman sa periodic table, lahat ng metals are located at the right part of your periodic table. Those that are non-metals are found at the left side of your periodic table. Divided sila ng place due to yung hagdan, no? na nakikita nyo highlighted part on your periodic table. That signifies those elements are metals or semi-metals na tinatawag. Okay? So they tend to lose. Kasi nga, marami pang electrons ang kailangan to reach stability. So what they keep on doing is to donate it and then reach stability. Yun yan. So for magnesium, dalawa, metal, they tend to lose. That's the technique. Fewer valence electron, metal, they tend to lose. So since fluorine is non-metal at maraming valence electron, tatanggalin niya pa ba yan? Common sense, hindi. So, like with this element, they tend to accept or gain electron. So, they will wait from another element to give their electrons to them just to reach stability. Okay? So, that's how you draw, illustrate the LEDS of a given element, and that also allows you to identify whether an element can lose, accept, or gain an electron. Okay? So, hope you learned something for today. That ends my discussion.